Good morning. In today's session, we have to study about the reversal of direction of rotation of the DC motor. We will wait for other students for 1 minute. Then we will start our session. Okay, you guys can wait for 1 minute. So we have studied about already as a DC motor. We know DC motor is having rotor and the stator. Rotor means what? Which part will rotate, and DC motor means what? Which will use the electrical energy and which will give us mechanical energy. So we have seen about the construction of DC motor, DC generator, generated EMF, back EMF, torque equations. We have seen about how many types of load we can use at the output side, how it will be related with respect to the armature. It means what? If armature will rotate at that time, that load will also rotate, and we can use load that can be used at domestic level, that can be used at agriculture level, or it can be used at the industrial level. Then I have seen the dynamics of the armature and the load. In today's syllabus we have to see about the reversal of direction of rotation of DC motor. So we are supposed to rotate the DC motor, and we have seen the working of DC motor, DC shunt motor. In that, what we are saying, EMF get introduced. How EMF will get introduced? When magnetic flux will get introduced. और magnetic flux कब create होगा? When we will give power supply to the DC motor or DC generator. At that time, we are using the transformer. It means what? We are using the inductor. We are using the field winding. It means what? When we will give the power supply, at that time magnetic flux will get introduced, and that magnetic flux will cut the conductor means we are using the armature as a conductor, so it will cut in a perpendicular manner. When it will conduct, when we will give the power supply and conductor will cut by magnetic flux, at that time EMF get introduced. But if you see in DC motor that EMF in opposite direction with respect to the supply voltage. That's why we are saying that EMF as a back EMF. So we have seen EMF will get introduced according to the Faraday's law, and we were using the flaming right hand rule to derive the direction of current. ये हम देख चुके हैं. But now in today's lecture, what we are supposed to do? We are supposed to reverse the direction. So if we are supposed to reverse the direction of rotation of the conductor, it means what? Armature. At that time we can use flaming left hand rule. It means what? If DC motor can turn in either clockwise direction or in anti-clockwise, or we can say in the counterclockwise, it can easily controlled by inverting the polarity of applied voltage. Because when we will give the power supply, we know the direction of magnetic field and current in the wire, we can see that direction of the resulting force. Because हमने flaming right hand rule देखा है. If we are saying like EMF get introduced according to the Faraday's law, and if conductor is placed in perpendicular direction with the magnetic flux, that time that current will be perpendicular with that magnetic field. ये हमने फ्लेमिंग राइट हैंड रूल में देखा है. बट व्हाट वी आर सपोज्ड टू डू हियर वी आर सपोज्ड टू रिवर्स द डायरेक्शन. सो वी कैन रिवर्स दैट डायरेक्शन ओनली मेकिंग द पोलैरिटी ऑफ अप्लाइड वोल्टेज रिवर्स. इट मीन्स व्हाट? हियर वी कैन रिवर्स द invert the polarity of our applied voltage. So the direction of force, the direction of rotation is explained here according to the Fleming left hand rule. And Fleming left hand rule क्या बोलता है? It says that if our first finger represents the magnetic field, you guys can practice there. You can take your left hand, you can put your first finger. It means what? Thumb के बाद का जो finger होता है. If your first finger is representing magnetic field. Here you can see, if it is representing magnetic field pointing straight down to the flower, मतलब तुम फ्लोवर के डायरेक्शन में नीचे स्ट्रेट डाउन ले सकते हो. एंड इफ इट इज रिप्रेजेंटिंग द डायरेक्शन ऑफ मैग्नेटिक फील्ड एट दैट टाइम यूर मिडल फिंगर, इट मीन्स व्हाट, जो तुम्हारा राइट हैंड है उसके बाद का फर्स्ट फिंगर छोड़ के जो सेकेंड फिंगर है, इफ your first finger is representing the direction of magnetic field, at that time your second finger will represent the current, and that will be pointing toward the computer screen. It means what, if downward लिख रहे हो first finger, तो second finger जो है it will be perpendicular to that finger, so it will be pointing towards the our computer, or if you are using your phone, so it will be perpendicular to your phone screen. So at that time your thumb represent the resulting force. When जब तुम तुम्हारा फर्स्ट फिंगर डाउनवर्ड रख रहे हो, सेकेंड फिंगर स्ट्रेट सामने रख रहे हो, एट दैट टाइम यूर थंब which is perpendicular to the first finger, it will represent the direction of force. You guys are supposed to understand about flaming right hand, flaming left hand rule, because when we have studied about the working principle of DC motor, DC जनरेटर, एट दैट टाइम देयर इज अ नीड ऑफ फ्लेमिंग राइट हैंड रूल. और जब कब वहां पे जहां पे तब तुमने ईएमएफ का इक्वेशन निकाला था, टॉर्क का इक्वेशन निकाला था, तब हम क्या कर रहे थे, फ्लेमिंग राइट हैंड रूल यूज कर रहे थे. बट व्हेन वी आर सपोज टू रिवर्स द डायरेक्शन ऑफ रोटेशन ऑफ आर्मेचर वाइंडिंग, or we can say when we are supposed to rotate reverse the direction of your DC motor. DC motor is nothing but we are taking as a armature because it is only a rotor part. Yeah, we are saying commutator, brushes, all these, but the main part is nothing but armature. So we can say here your thumb will represent the force directions which points the left. ये जो left direction बताएगा, because जब तुम first finger, तुम्हारा first finger downward रख रहे हो, उसके परपेंडिकुलर में सेकेंड फिंगर तुम फॉरवर्ड डायरेक्शन में रख रहे हो, तो ऑब्वियसली योर थंब विल बिकम परपेंडिकुलर व्हिच विल बी इन लेफ्ट डायरेक्शंस एंड व्हिच विल बी परपेंडिकुलर विथ योर first finger. So here we can say when we are supposed to reverse the direction of rotation of armature winding of the DC motor, at that time we can use flaming left hand rule. So this will show that with the current flowing through the wire into the computer screen will cause force pushing left in our model, because we know here our thumb will representing left directions. So here we can say that current flowing through the wire into the computer screen will cause a force pushing left. This is equivalent to motor that will be in the counterclockwise directions. Is there any issue? Roshan, please mute yourself. Okay. So it will give us directions that will be reversed, and here we are giving only inverse applied voltage. मतलब जो पॉजिटिव और निगेटिव जो पहले वोल्टेज दे रहे थे उसकी सिर्फ हम पोलैरिटी चेंज कर रहे हैं. यू कैन सी हियर आई हैव एक्सप्लेन्ड हियर आल्सो द डायरेक्शंस, बट इट विल show us in the opposite directions because this is the opposite image, mirror image. So here you can say if we are putting our first finger which will be downward, this ब्लू कलर के जो एरो है ये जो डाउनवर्ड है, प्लीज डोंट डिस्टर्ब द क्लास. महेश प्लीज म्यूट योरसेल्फ. You can see here this we are taking north and south pole. So when that magnetic flux, magnetic field is going downward, which is our first finger, at that time your second finger which will represent towards our screen, so you can take our current that will be toward our screen. So if we are taking towards our screen, तो force क्या हो जाएगा, it will be in left direction. But here, if you see, that will be in opposite mirror image. So that's why it is showing here. So it will be in left directions with respect to this, and it will give us the direction of force. So here we can say here. So how we can change the force so that that wire will travel in the opposite direction. Actually क्या हो रहा है? Force is going here. But what will be needed? We are saying we are supposed to use Fleming left hand rule. We are supposed to give reverse input voltage. It means what? We can supposed to invert the polarity. So here we can say here we are supposed to change the force directions so that wire travels in the opposite directions. So our motor will rotate in the reverse direction. So here we can again use Fleming left hand rule with the same magnetic field, but here our thumb will represent right instead of left. You can see here यहाँ पे जो thumb था, यहाँ पे thumb कहाँ जा रहा था, this side जा रहा था. But here if you see, thumb will go to the right side instead of the left side. So as a result, our second finger that will show now point towards the ourself. क्योंकि जब यहाँ पे हमने फ्लेमिंग लेफ्ट हैंड रूल यूज किया था, तब हमने क्या बोला था? When we are putting our first finger downward, it's blue lines downward. At that time, our second finger will represent the direction of current that will be towards screen, मतलब सामने के डायरेक्शन में. तो जब हम ऑपोजिट कर रहे हैं, at that time what will happen? जो हमारा सेकेंड फिंगर रहेगा, जो हमारा सामने की तरफ जा रहा था, it will come towards ourselves. So here we can say our second finger, middle finger, that will be towards ourselves and it will be shown us the direction of current. Magnetic field जो है, it will be go downward. But here if you see, current का जो screen, current का जो direction है, it will be opposite to the screen, it will be towards ourselves. And force का direction है, वहाँ पे left में जा रहा था, यहाँ पे force का direction, it will go to the right side. So as a result, we will get here current that will be flow out of screen. This shows that in order to make rotor clockwise or anti-clockwise, we are supposed to reverse the direction of current. By making the direction of current reverse bias, we will get DC motor that will be go in the reverse direction. If we are making clockwise and if we are making the current out of phase, 180-degree phase difference, at that time you will get here that motor will rotate in the 180-degree out of phase. It means what? It will rotate in the anti-clockwise. Only by making the current directions opposite phase, we can reverse the direction of force. Pawan Kumar, please mute yourself. काफी नए लोग दिख रहे हैं. Okay, हाँ. So here we can say here by making the direction of current reverse bias, we can make rotation of DC motor that will be rotate in the reverse bias. So in order to change the direction of rotation, we can only make our voltage that will be in reverse bias. Siddesh. Okay. It means what? By making our input voltage, which we are giving, if we are changing the polarity, we can change the direction of current. And by changing the direction of current, we can make motor that can be rotated in a clockwise or in anti-clockwise direction. It means what? Motor का जो direction से we can change, we can get reverse by changing the polarity. So simply in order to change the direction of rotation of DC motor, we can simply reverse our supplied voltage. That will cause to current to change the polarity, and as that current will change in polarity, force will get 180-degree reverse bias. Here we can see here, when we are giving the positive voltage, at that time force will go to the left side. But when we are giving the polarity change of the supplied voltage, at that time that force will get 180-degree out of phase with respect to that force. So here we can say our motor will go to the reverse directions, and that motor to be driven to the backwards. If you see here, this is the circuit diagram. You can see when we are giving this block is nothing but power supply. ये ब्लू ब्लैक कलर का जो रेक्टेंगल दिख रहा है, here only we are giving the power supply. So when we are giving the power supply, north and south, these are nothing but the poles. ये जो arrow है, these are nothing but the magnetic field, and F is nothing but force. So we have seen when we are giving the positive supply, ये first diagram, when we are giving here positive supply, when we are giving positive supply to the DC motor, at that time it will rotate in a clockwise directions, because you can see here our force will go to the this side. But when we will give the negative polarity, at that time you can see our force directions will get changed, because when we will give the negative power supply, at that time our motor will start to, यहाँ पे तुम देख सकते हो मोटर क्लॉकवाइज डायरेक्शन में, बट यहाँ पे मोटर के बीच में ये जो मैंने ब्लू कलर का, you can see here when I have drawn that blue color arrow, at that time I have shown it is reverse bias with respect to this arrow, or we can say it is in the opposite directions, or we can say it is in the anti-clockwise directions. So here we can rotate, we can reverse the direction of DC motor by changing the polarity of supplied voltage. Same diagram I have shown here. So what we are saying is the direction of magnetic field in which current carrying conductor is placed, because here we are using the armature. So we know it is nothing but it is a good conductor, and when magnetic flux will get introduced, that if we are putting that conductor in the magnetic flux, at that time the direction of main field is reversed, because here force that will experiences the conductor will reverse the directions. You can refer a case A or C, A and C, or B and D. You can see here A and C both are having opposite, when we are giving the positive supply, when we are giving the negative supply. And you can see, or this also, you can see here B and D also, these also force are having the opposite direction. So if we are changing the direction of supplied voltage, we will get the direction of rotation of DC motor that will get reverse biased. That if that motor will rotate in clockwise, and if we are changing the direction of power supply, we will get the motor that will rotate in the opposite direction. So however, if both directions are reversed, the direction of force will experiences the same. It means what? If we are changing the both directions, if we are changing the directions of current, and you can say similarly, if we are making the flux unchanged, if we are not changing the flux amount, only we are changing the direction. Direction of which? Direction of current, which will pass through the conductor. Or we are making here the direction of magnetic field. If the direction of magnetic field is get changed, is get reversed, मतलब हम क्या कर रहे हैं, if we are supposed to change the direction of DC motor, change the rotation of DC motor, at that time either you can change the direction of current, or we can change the direction of magnetic field. You can see here मैंने क्या किया है, magnetic field this side लिया है, or you can take to this side. If we are changing, ये यहाँ पे तुम देखोगे, when A or B, if we are taking magnetic field in the upward direction, और यहाँ पे C और D में देखोगे तो मैंने magnetic field क्या किया है, ये एरो जो है, ये 1 2 3 4, ये 8 एरो, ये जो लाइन पे दिखाए हैं मैंने, ये क्या किया है, मैंने डाउनवर्ड लिया है. यू कैन सी हियर डायरेक्टली. हाँ, इफ वी आर चेंजिंग दिस डायरेक्शंस, ये मैं तो एक डाउनवर्ड ले रही हूँ या फिर अपवर्ड ले रही हूँ, या फिर करंट का डायरेक्शन इफ वी आर टेकिंग टूवर्ड्स अवर सेल्फ और इफ वी आर taking the current directions towards the computer screen. We can do these two things. If we are doing one of these two things at that time, we will get direction of rotation of DC motor that will be reverse biased. Reverse. If we are changing both, if we are changing the direction of current as well as if we are changing the direction of magnetic field, what will happen, that motor will not get reverse biased, that will not get in the reverse directions, because if both directions are reversed, the direction of force experience the same and it will not reverse the rotation of DC motor. It means what? Only we are supposed to change the direction of current, or we can supposed to change the direction of magnetic field. At that time, we can change the rotation of DC motor. It is very simple. There will be question like, explain the working principle for the reversal of direction of rotation of DC motor, or sometimes how to reverse direction of DC motor. At that time, you are supposed to write about Fleming left hand rule. You are supposed to write, if this question is in long mark, it means 3 to 4 months. At that time, you are supposed to explain about Fleming left hand rule. You can draw this diagram or one diagram. You can draw only one and you can explain what will happen if you are changing the direction. And you are supposed to draw this diagram also. Ye diagram you are supposed to draw. And you can show here if you are giving the positive supply and if you are changing the direction of power supply, what will happen. And you are supposed to write only these two things. If we are changing the direction of magnetic field and if we are changing the direction of magnetic field, we will get मैग्नेटिक फील्ड का डायरेक्शन चेंज कर रहे हैं, या फिर इफ वी आर चेंजिंग द डायरेक्शन ऑफ करंट, वी विल गेट द रोटेशन ऑफ डीसी मोटर दैट विल गेट रिवर्स बायस. And if we are changing both at a time, at that time the direction of force will not change and it will experience the same value, so we will not get rotation of DC motor reverse. So in practical motor, to reverse the direction of rotation, either we can change the direction of magnetic field that is produced by the field winding. We can change that direction or we can change the direction of current which is flowing through the armature. We can change that direction or we can change the direction of magnetic field. And the direction of main field can be reversed by changing the direction of current passing through the field winding. So if we are interchanging the polarities of power supply, we can change the direction of current or we can change the direction of magnetic field. So here we have seen about how to reverse the direction of DC motor. If we are having the DC motor and if we are supposed to give the brake, so here we are supposed to see about braking in DC motor. If we are running DC motor and if there is any inconvenience, it means what? If we are facing any issue and we are supposed to make that DC motor pulse, so we can give a brake. So here we are supposed to study about how to use electrical braking in the DC motor. If we are supposed to make running DC motor that can be brought to rest position, मतलब रोटेट हो रहा है बट सडनली, जैसे तुम गाड़ी पे ब्रेक देते हो व्हेन यू गाइस आर ड्राइविंग लाइक दिस, इफ डीसी मोटर रोटेट है बट इफ देयर इज एनी inconvenient happening and we are supposed to give the brake, at that time we can make our DC motor to rest condition by giving the brake. So electrical braking is usually employed in applications to stop unit driven by DC motor in exact position to have a speed of driven unit suitably controlled during deceleration. मतलब accelerate मतलब if it is rotating, if it is in having speed, and if we are supposed to make that rotor as a stationary, so we can give the electrical brake. So electrical brake is used in applications where we will require emergency stops, where we will require frequent stop. Electrical braking allows us smooth stop without any inconvenience to the passengers. Sorry. When loaded hoist is lowered, electrical braking keeps the speed within safe limit, or it will drive speed that will reach dangerous values. It will give us stop. It means what? It can make emergency stop. And when train goes down, steep gradient electrical braking is employed to hold the train within a prescribed safe limit. So, in spite of electrical braking, the braking force can also be obtained by using mechanical brakes. There are different types of electrical braking like regenerative braking, dynamic rheostat braking, plugging or reverse current braking. And if you see, there is one disadvantages of the braking in DC motor, because when we are supposed to give brake, at that time more amount of power will get waste in form of heat. So we can say braking power is wasted in the form of heat when we are giving the brake to the DC motor. It will require frequent maintenance, and it will require replacement of brake shoes. So it will get more cost. So as we will supposed to give maintenance more frequently, and we are supposed to replace the brake shoes, it will require cost. So we can say it is having higher cost, and here braking power is wasted in the form of heat. This regenerative braking concept we will see in the next class. So in today's session we have seen how to reverse the direction of DC motor. If we are supposed to reverse the direction of rotation of DC motor, we can use Fleming left hand rule. Fleming left hand rule states that if we are keeping our first finger, that will be in downward directions, and if it will representing the magnetic field, at that time our second finger will represent the direction of current, and it will be represent directions which will be in perpendicular with our first finger, and it will be go in the directions that will be towards our computer screen. And at that time our thumb will become left, it will show the left direction. And if we are supposed to reverse the direction, at that time we can make changes in the polarity of supplied voltage. If we are changing the polarity of supplied voltage, at that time either the direction of magnetic field will get changed. It means what? Magnetic field जो downward जा रहा है वो ऊपर के साइड रहेगा, or we can change the direction of current. If direction of current is going to the forward side, if we are supposed to reverse the direction of DC motor, and if we are changing the direction of polarity of supplied voltage, at that time that current will go out of phase with respect to screen, and it will show us direction which will be towards ourselves. And here if you see, we will get the force that will be having 180-degree phase difference. If you see here, when we are giving the voltage which will be positive, at that time force will go to the left side, but here force will go to the right side. So here we can change the direction of rotation of DC motor only by changing the direction of supplied voltage, that will cause to change in direction of current. Here we can see, here we can change the polarity of voltage, or we can change the direction of current by changing the polarity of voltage, or we can change the direction of magnetic field. If it is going in upward directions, we can make the direction of magnetic field in the downward by doing one of these two things, by changing the current or by changing the magnetic field. We can make that DC motor in the reverse directions if it is moving in clockwise. So if we are making the opposite polarity voltage, we will get here direction of DC motor that will be go in the anti-clockwise direction. So here we can say if we are changing both, if we are changing the magnetic field as well as we are changing the direction of current, the direction of force will experiences the same value and rotation of DC motor will not get changed. So here only we are supposed to change only one thing. Now we are supposed to study about the braking in DC motor. If we are supposed to stop our rotating DC motor, we can give electrical brake. So electrical braking is usually employed in applications to stop unit driven motors in exact position which is having the speed. Here, by using the electrical braking, we can give emergency stop. We will get accurate and quick stop by giving the electrical braking, and it will allow smooth stop without inconvenience to the passenger. When loaded hoist is lowered, electrical braking keeps the speed that will be in the safe limit. So electrical braking we can use where active loads are applicable, and in spite of electrical braking, we can make braking force that can be obtained by using the mechanical brakes. But here if you see, there are some disadvantages also. It will waste a larger amount of power in the form of heat, and it will be required more frequent maintenance and replacement of the brake shoes. Braking power is wasted in the form of heat. If you see, there are some different types in the electrical braking like regenerative braking, dynamic rheostat braking, plug-in, reverse current braking. Now I am taking your attendance. Wait for 1 minute. Remaining syllabus we will see in the next session. Okay. I will provide these PPTs. I will provide these our online lectures on YouTube. I am sharing in classroom. On the end of our unit, I will share in WhatsApp group also, and I will share assignment for this unit. You guys are supposed to submit all 3 assignments on 3 units in tomorrow's session. We will finish our this unit. After that, mostly on Thursday or Friday, we will take unit test. There will be 15 questions. Each question will have 2 marks. जैसे पिछला पैटर्न है वही पैटर्न रहेगा. थर्सडे को हम टेस्ट लेंगे. Okay. Thank you. You guys can leave now.
Ma'am, how we have to submit our assignments?
You guys can submit assignment in classroom. Classroom join किया है तुमने?
हाँ मैम.
किया है join?
Yes ma'am.
हाँ तो वहाँ कर सकते हो ना सबमिट. वहाँ ऑप्शन रहता है ना सबमिट का.
Okay, okay, I'll submit.
हाँ, okay.
Yes.
If you face any issue, you can call me. Okay.
Okay.
Is there any issue to other? Real Kunal?
No, ma'am.
Okay.
No, ma'am.
Okay, you guys can leave now.
Okay.
Kashif, is there any issue?
Okay, thank you.